Find the position vector of a particle that has the acceleration vector at equaling e to the negative t 4t e to the t, along with the initial velocity v naught equaling vector k, and the initial position r naught equaling j plus k. Now, the first thing to realize here is when I think of v naught equaling this k here, remember what the unit vector k means. It's actually the vector 0, 0, 1. It's in the z direction, 1 unit. So 0, 0, 1 is that vector. And r naught, when I see this j plus k, I should understand that this is 0, 1, 1. So knowing those two pieces of information, we'll use those, but not right now. But it's good to understand your problem fully before you get into it. All right, so the first thing now we're going to have to do is when I think of acceleration, I need to find the position vector of a particle. So that's my RT. So I need to find RT here, and I'm at AT. So if I took the derivative of RT, that's equal to velocity, if you didn't know that. And then if I take a derivative of velocity, that's equal to acceleration. Or I can say that this, to get acceleration, is going to be r double prime of t. I can also say that. So since I'm dealing with acceleration to begin with, then to get the velocity, I would have to integrate the acceleration. When I integrate it, I'll get velocity. So that's going to be our avenue we're going to take with this problem. So we need to start with an integral of our acceleration function. So the integral of e to the negative t, comma, 4t, comma, e to the t, dt. That's going to equal negative e to the negative t plus c1, comma, 2t squared plus c2, comma, e to the t plus c3. Since we have these initial conditions for both velocity and position, we'll be able to find out what C1, C2, and C3 are specifically. That's the nice thing about having initial values. So since we know V naught is equal to 0, 0, 1, and we know when we integrate acceleration that it equals Vt, then if I plug in 0 for my t's here, then I know I should get 0, 0, 1. So that's what we're going to do now. So we're going to take this, because this is really our Vt plus c, so to speak. And we're going to say, hey, if I plug in zeros for my t's, plus c1, comma, 2, 0 squared plus c2, comma, e to the 0 plus c3, and that should equal 0, 0, 1 because of what it said up there. Because it said that initial was equal to a vector k. So that tells me then that this here, what is that? That's going to be negative 1. So negative 1 plus c1 should equal 0, because this here equals this here. That first component equals the first component. And the second component equals the second component. And the third component equals the third component. So we're just going to write those out now. So then for C1, in solving this, my C1 is going to equal 1. Okay, now the same thing for C2 I'm going to do now. So that's going to be a 0. So C2 equals 0 because it has to equal the other side. And then C3, e to the 0 is 1. So 1 plus C3 equals 1. So then when I subtract 1 from both sides, C3 equals 0. So now we have the specific velocity function now. So that velocity function then, with using this information, implies velocity, my Vt, equals negative e, to the negative t plus 1, comma, and then 2t squared, comma, and then e to the t. And that's going to be my Vt now. And to get to the position vector, I have to integrate my velocity. So that's what I'm going to do now. So I'm going to take the integral of negative e to the negative t plus 1, 2t squared, and e to the t, dt. So now I'm going to integrate these now. So the integral of negative e to the negative t is going to be e to the negative t plus t plus c1. And for the next one, it's 2/3 t cubed plus c2, comma, e to the t plus c3 dt. Oh, no dt. I integrated. Okay, so now what we're going to do here is we know that r naught equals 0, 1, 1. So now we're going to just plug in zeros because it says when I plug in 0 for r, 0 for t, into r, then I'm going to get 0, 1, 1. So we're going to use that same idea here at the bottom again. So that's really going to be e to the negative 0 plus 0 plus c1, comma, 2/3 0 cubed plus c2, comma, e to the 0 plus c3, and that's supposed to equal 0, 1, 1. So then for the first one here, this is going to be a 1. That's 0, so I get plus c1, and that should equal 0, because it has to equal the first component on the other side there. And then my next equation, I'm just going to run through these equations so you can see how they all kind of play out here. So then this is just going to be a 0 there for this whole piece. And then that's really just C2 equals 1. And then for the third piece here, that's going to be 1 plus C3, and that equals 1. So when I move that over, that's going to be C3 equals 0. And this piece here, the C1, is going to equal negative 1. So that tells me then my RT, and that's what I needed to find was my RT, that my RT is going to equal e to the negative t plus t. Oops, I was going to write plus 1, but it's minus 1, comma, and then 2/3. Oops, let me fix my 3 there. T cubed. So no. Plus 1, because that's my C2 here. Comma. And then for my C3 is 0, and this is my third piece here. So that's just going to be e to the t, because it's plus 0. So there is my RT. Now again, keep in mind, it's not just the answers that I need for these. I also need to see all this work in order to get full credit if I give you a problem like this on the test. So there's the answer.